Could a solar storm shut down modern life? Today we separate movie myths from physics, what a Carrington-level event is, what's changed since 1859, and how we actually prepare. Solar superstorms begin with the sun. Magnetic fields twist, store energy, and erupt as flares and coronal mass ejections. A CME is a huge cloud of magnetized plasma launched into space. If it's aimed at Earth and the magnetic orientation couples strongly, geomagnetic storm time begins. When CME plasma hits the magnetosphere, energy couples into Earth's magnetic field. Rapid changes in the field induce electric currents, geomagnetically induced currents, or GICs, in long conductors on the ground and in orbit. In 1859, telegraph systems sparked and auroras reached the tropics. The event was extreme, but there was no global grid, no satellites, no GPS. Comparing 1859 to today requires understanding what's vulnerable now, not copy-pasting history. A strong storm in 1989 drove GICs that tripped protection systems and collapsed Quebec's grid in seconds. That event wasn't Carrington class, but it showed how long conductors and certain transformer designs can be stressed. Power grids. Long transmission lines and some transformers are GIC sensitive. Satellites, surface charging, drag increases in the upper atmosphere, and radiation dose. Aviation, HF radio and polar routes. Navigation. Ionospheric disturbances degrade GPS accuracy. Subsea cables are fiber optic. Glass doesn't conduct GICs, but they use powered repeaters connected by long conductors. Risk depends on cable design, route, and protections. It's an area of active assessment, not guaranteed outage. No, a solar storm does not literally fry everything. Effects depend on storm strength, magnetic orientation, latitude, ground conductivity, and engineering protections. Impacts are real, but uneven and manageable when planned for. We monitor the sun with satellites and ground observatories. Coronagraphs measure CME speed and direction. When a CME is Earth-directed, forecasters estimate arrival windows and likely storm intensity with indices like KP. In situ measurements at L1 refine warnings. Grid operators can reconfigure networks, reduce loading, and watch transformer-neutral currents. Satellites can safe mode, adjust attitude, orbits, and operations. Air traffic can reroute from polar paths and switch comms bands. A moderate storm in 2022 increased atmospheric drag, causing the loss of newly launched small satellites that hadn't raised their orbits. The lesson: operations matter. Timing and altitude can make the difference. Severe storms are low frequency, high impact. The prudent approach is layered defense, better forecasting, engineering standards for GICs, satellite hardening and drills. Preparedness beats panic. We have far more to lose, but also far more tools: space weather centers, global monitoring, operational playbooks, and standards. Blackouts are possible. Long-lasting global collapse is not an evidence-based baseline. Solar superstorms are serious, just not apocalyptic by default. Understand the physics, respect the risks, and invest in resilience. For more science, clearly explained, subscribe to KnowverseTV.